Whenever you have given these problems a try, we can continue the video and go over the solutions together. For part 8, we see that directly the numerators we started with were u and u squared. We don't want u or u squared to be 0, so we actually get a result of u doesn't equal to 0, no matter which one you're working with directly. But in addition, we want to make sure 2 plus 1 over u doesn't equal to 0, and to solve that, we can multiply both sides by u. You can alternatively just subtract 2 on both sides. I just want to introduce this method as well if you want. And if we subtract 2 on both sides, we would get 1 over u doesn't equal to negative 2. And to solve for that, you can treat it in two different ways. You can kind of think about 1 over u is really the reciprocal of u, and therefore that tells me u doesn't equal to the reciprocal of negative 2, which is negative 1/2 over here. Alternatively, you can also go through the process of multiply u on both sides over here in this step, and that gives us 1 doesn't equal to negative 2u, and to find u, we divide negative 2 on both sides and get negative 1/2 as well. So no matter which method you use, you should get u doesn't equal to negative 1/2. And that gives us our original domain. U doesn't equal to 0 and u doesn't equal to negative 1/2. Now looking at the function, we have the least common denominator just being u squared. So multiply everything by u squared. I'm just going to write it over here. Everything's getting multiplied by u squared, every single term. So on top, I would just have 8u plus 4. On the bottom, I have 2u squared plus u. Now let's check any GCF. And also, just to remind you, when we work with LCD, we're always making the assumption that LCD doesn't equal to 0, so technically we're making the assumption u doesn't equal to 0 here by using the LCD. And now, to factor out the GCF on top, it's 4. That leaves us 2u plus 1. On the bottom, GCF is u, leaving 2u plus 1 as well. Now if we go through the cancellation, in order for them to cancel, we rely on the fact 2u plus 1 doesn't equal to 0. In other words, we can say u doesn't equal to negative 1/2 is what we incorporated. And then we're left with 4 over u. And for the final expression, the domain is going to be u doesn't equal to 0 as a result. So the change occurred for u doesn't equal to negative 1/2, which we saw that we need to use in order to do the cancellation. Moving on to part B, I just have a denominator of t in both the top and bottom. So t doesn't equal to 0. Also, I want the entire bottom to be non-zero. And we can do the same trick as what we did in part A. So I can get 9 doesn't equal to 2 over t, and with this we can multiply t on both sides. And again, that's based on the fact t doesn't equal to 0, or the domain restriction, t doesn't equal to 0, which we listed. And 9t doesn't equal to 2, and therefore t doesn't equal to 2 over 9. So the domain was t such that t doesn't equal to 0, or 2/9. Now looking at simplifying the entire function, the LCD is just t. So that means I can just multiply t to everything, and that again relies on the fact that whatever I'm multiplying doesn't equal to 0. In this case, t doesn't equal to 0 over here. And when I do this, I would end up with 7t plus 3 over 9t minus 2. No cancellation whatsoever. They're both linear. There's no factoring we can do further. And that just leaves the final domain to be what we already solved earlier. If we want 9t doesn't equal to 2, that means t doesn't equal to 2/9. So the domain restriction changed at 0, which we used for the least common denominator, but it's not reflected directly in the final denominator. Now for, again, part C, not part A, we would have this problem, and the denominator we directly have is x plus 1 doesn't equal to 0, so x doesn't equal to negative 1. And then we also have to make sure 1 plus 1 over x plus 1 doesn't equal to 0. So in order to solve that, I can again subtract 1 on both sides. 1 over x plus 1 doesn't equal to negative 1, and I can multiply x plus 1 on both sides. I can do this again based on the fact that I have the domain restriction x plus 1 doesn't equal to 0 listed. Once I do so, I would get 1 doesn't equal to negative x minus 1 over here. And to solve it, I can add 1 on both sides. 2 doesn't equal to negative x, or x doesn't equal to negative 2. Therefore, the domain restriction is x such that x doesn't equal to negative 1 and x doesn't equal to negative 2. Now with this, we can look at the least common denominator is just x plus 1. And again, in order for us to simplify, we can multiply x plus 1 to everything, but make sure you note that we're really using the restriction that this is not equal to 0, or x is not equal to negative 1. And when we simplify this, we would get x plus 1 would cancel out in the first term, so we're just left with 1 minus x plus 1 over x plus 1 plus 1 over here. So altogether, we get negative x on top, because once you distribute a negative sign, that negative gets to 1, and 1 minus 1 cancel out. On the bottom, I have x plus 2. Again, no cancellation over here, but we do have a domain restriction for the result being x doesn't equal to negative 2 over here. And that negative 1 restriction is kind of invisible, only looking at the final result, but it was being used in the LCD. Lastly, for part D, we want to make sure that our denominators are not equal to 0, and if you notice, x squared minus 4 doesn't equal to 0 would actually require x plus 2, x minus 2 doesn't equal to 0, which are the other two denominators. So if you just solve this one, you will get the same restriction for everything based on just the current denominators. And now we also want to make sure the entire thing on the denominator, that rational expression, doesn't equal to 0. And in this case, it's a little bit interesting. You can notice it by, if you try to multiply x squared minus 4 on both sides, you will get the result that 6 doesn't equal to 0, which is a true statement, always. That's because if I want this rational expression to be equal to 0, that would require the numerator to be 0. Here, the numerator is not equal to 0, because 6 doesn't equal to 0. We get that this is always true. Then we would have this whole thing is always going to work. So we can say this is always true, that our denominator currently will never be 0. So the only restriction we get is just x such that x doesn't equal to plus or minus 2. And with this, we can work with the least common denominator of x plus 2, x minus 2. We already said this incorporates everything already. That means I'm going to basically multiply everything by x plus 2, x minus 2. And on top, the first term will turn into 2 times x plus 2, because that factor of x minus 2 is cancelled out, plus 1 times x minus 2. This is over, on the bottom, just 6, because x plus 2, x minus 2 is equal to x squared minus 4. That's what we listed. And just by using the LCD, we are using the fact that x doesn't equal to plus or minus 2 over here, which were in the domain restriction. But just want to bring this to your attention again. And now we can just simplify the numerator. 2x plus x would be 3x, and when we distribute the 2, we would get a 4 for the constant in the first part, and a -2 from the second. So plus 4 minus 2 will be plus 2 all over 6. We can't really factor it anymore. And in the final answer, you can see if we just look at the final result, the domain is actually all real numbers. You can use a set of real numbers over here. And in this case, if we look at the domain restriction, we don't have 2 or -2 as a restriction at all if we just look at the final answer, but we had to use that condition when we're going through the simplification process.